Good morning, children. In your previous class, you have studied about the universal law of gravitation. You just recall it, children. Universal law of gravitation states that every object in the universe attracts every other object with a force which is proportional to the product of their masses and inversely proportional to the square of the distance between them. And the force is along the line joining the centers of two objects. This is universal law of gravitation, children. In equation form, we can write it as F equals to G, M into M by D square. Here, G is the universal gravitational constant and M and small m, they are the masses of the two objects and D is the distance between them. Now today, children, we will solve some examples and also we will study about the free fall. Here, one example is there here, children. The mass of the earth is 6 into 10 raised to 24 kg and that of the moon is 7.4 into 10 raised to 22 kg. If the distance between the earth and the moon is 3.84 into 10 raised to 5 kilometer. You write here into, children. Now you have to calculate the force exerted by the earth on the moon. Here the value of gravitational constant has been given here. G equals to 6.7 into 10 raised to minus 11 Newton meter square per kg square. This value, it is universal gravitational constant, children. Now solution, here the mass of the earth has been given here. M equals to 6 into 10 raised to 24 kg and the mass of the moon M equals to 7.4 into 10 raised to 22 kg. The distance between the earth and the moon, that is D equals to 3.84 into 10 raised to 5 kilometer. Now you convert this into meter, children. That is 3.84 into 10 raised to 5 into 1000 meter. You will get here 3.84 into 10 raised to 8 meter. Now the value of gravitational constant, that is G equals to 6.7 into 10 raised to minus 11 Newton meter square per kg square. Now you have to calculate the force exerted by the earth on the moon. From equation 10.4, children, this in previous class we have already studied this. That is F equals to G, M into M by D square. Now substitute the values here. G is 6.7 into 10 raised to 11 Newton meter square per kg square and M is 6 into 10 raised to 24 kg into 7.4 into 10 raised to 22 kg and D, that is distance between the two objects, these children, 3.84 into 10 raised to 8 meter whole square. Now after calculating this, children, you will get 2.01 into 10 raised to 20 Newton. Thus, the force exerted by the earth on the moon is 2.01 into 10 raised to 20 Newton. This is the force exerted by the earth on the moon. Now, what is the importance of universal law of gravitation? We will study that, children. The universal law of gravitation, it successfully explained several phenomena which were believed to be unconnected. See, children, these four phenomena, these were explained by the universal law of gravitation. First one is the force that binds us to the earth, that is gravitation, children. And the moon motion, that is the motion of the moon around the earth. The motion of the moon around the earth. And third one is the motion of the planets around the sun. And fourth one is the tides due to the moon and the sun. Tides mean, children, it is the rising and falling of the sea. It is because due to the moon and the sun. These four phenomena, that is because of the gravitational force, we will attracted towards the earth. This was explained by the universal law of gravitation. And also children, the motion of the moon. The moon, it is the moon, it does not rotate children. The moon, it spin on its axis, completing a rotation once every 27.3 days. And here the confusion is caused because it also takes the same period to orbit the earth, so that it keeps the same side facing us. That is the motion of the moon around the earth. This was explained by the through universal law of gravitation. And also the planets, they revolve around the sun, and the tides, they are due to the moon and the sun. These four phenomena, these were explained through universal law of gravitation. Next, we will study about the free fall. Let us try to understand the meaning of the free fall, children, by performing an activity here. You take a stone, children, throw it upwards. See, whenever you throw an object, it reaches a certain height and again it starts falling down. See, you throw any object, it will reach some height and again it fall towards the ground only. We have learned that the earth attracts the objects towards it. This is due to the gravitational force. Now, whenever the objects fall towards the earth under this force alone, we say that the objects are in a free fall. See children, whenever the objects fall towards the earth under the gravitational force alone, we will say that the objects are in a free fall. Now, is there any change in the velocity of the falling objects? See, while falling, there is no change in the direction of motion of the objects. But due to the Earth's attraction, there will be a change in the magnitude of the velocity. See children, here, whenever the object falls down, there will be no change in the direction of the motion of the object. Means it will travel in the same direction, but due to the Earth's attraction, there will be some change in the size of the velocity. Now, any change in velocity, it involves the acceleration. Whenever an object falls towards the Earth, an acceleration is involved here. This acceleration is due to the Earth's gravitational force. Now, therefore, this acceleration, it is called as the acceleration due to the gravitational force of the Earth, or it is also called as acceleration due to gravity. It is denoted by small g. See children, here whenever an object falls, it moves in the same direction, but due to the Earth's attraction, there will be some change in the size of the velocity. Now, any change in this velocity, it involves the acceleration. Now, this acceleration is because of the Earth's gravitational force, and it is called as the acceleration due to gravity. It is denoted by small g. Now, the unit of g, it is the same as that of the acceleration, that is meter per second square. This is the SI unit of acceleration due to gravity. And we know from the second law of motion, children, that is force is the product of mass and acceleration. Now, let the mass of the stone in activity 10.2 that we previously studied with this, it be m, and we already know that there is an acceleration involved in falling objects due to the gravitational force, and it is denoted by g. Therefore, the magnitude of the gravitational force F will be equal to the product of the mass and acceleration due to the gravitational force, that is F equals to m into g. Here see children, the unit of g is meter per second square, and we know from the second law of motion that is force is the product of mass and acceleration, that is m, if F equals to m into a. Now let the mass of the stone in the activity 10.2 be m. Now we already know that there is an acceleration involved in falling the objects due to the gravitational force, and it is denoted by g. Therefore here the magnitude of the gravitational force F will be equal to the product of the mass and the acceleration due to the gravitational force. That is here F equals to m, and a acceleration, it is replaced by the here acceleration due to the gravitation, that is g. Therefore we will get here F equals to m into g. Now from equations children 10.4, this we have already studied in our previous class, that is F equals to gm into m by d square, and equation 10.6, that is F equals to m into g. We have, now we can equate these two equations. We will get here m into g equals to g into m by d square. That is here both the m, they will cancel here. We will get g equals to g m by d square, where m is the mass of the earth here and d is the distance between the object and the earth. Now let an object be on or near the surface of the earth. Now the distance d in equation 10.7 will be equal to r, that is the radius of the earth. See here children, now let an object it be on or near the surface of the earth. Now the distance d, this d will be equal to r here children, that is this d will be equal to the radius of the earth. Thus for the objects on or near the surface of the earth, for the objects on or near the surface of the earth, we will have m into g equals to g m into m by r square. Here d is replaced by r, that is radius of earth, r square. Again you will get here g equals to g m by r square. The earth is not a perfect sphere. See children, the earth is not a perfect sphere. As the radius of the earth increases from the poles to the equator, the value of g becomes greater at the poles than at the equator. See children, here children, equator means it is an imaginary line around the middle of the planet or any other celestial body, and it is halfway between the North Pole and the South Pole at 0 degrees latitude. And equator, it divides the planet into a northern hemisphere and the southern hemisphere, and the earth is widest at its equator. Now as this radius of the earth increases children from the poles to the equator, the value of the acceleration due to gravity, that is g, it becomes greater at the poles than at the equator. And for most calculations we can take g to be more or less constant on or near the earth, but for the objects far from the earth, the acceleration due to the gravitational force of earth is given by the equation 10.7 children. Here that is g equals to g m by d square. See children, here we can take acceleration due to gravity g to be more or less constant on or near the earth, but here for the objects far from the earth, the acceleration due to the gravitational force of the earth, it is given by g equals to g m by d square. Here we will calculate the value of g. To calculate the value of g, we should put the values of g, m and r in equation 10.9. That is 10.9, it is g equals to g m by r square. Here d is replaced by r, that is radius of earth children. Here And also the universal gravitational constant G equals to 6.7 into 10 raised to minus 11 Newton meter square per kg square. Mass of the earth, that is m equals to 6 into 10 raised to 24 kg, and the radius of the earth r equals to 6.4 into 10 raised to 6 meter. Here see children, we have to calculate the value of G here, and we should put the values of the universal gravitational constant and also the mass of the earth and radius of the earth in equation 10.9. That is 10.9 is G equals to Gm by r square. Now you substitute the values here children. G equals to gravitational constant is 6.7 into 10 raised to minus 11 Newton meter square per kg square, and mass of the earth is 6 into 10 raised to 24 kg divided by radius of the earth, that is 6.4 into 10 raised to 6 meter whole square. Thus, the value of the acceleration due to gravity of the earth, after calculating this children, you will get here G equals to 9.8 meter per second square. This is the value of the acceleration due to gravity. This is constant children. This value will not change. This is the constant. That is the value of acceleration due to gravity is G equals to 9.8 meter per second square. Understood children? Till now we studied about the importance of universal law of gravitation and also free fall. Now some questions have been given here children. You write the answers for these. Next, we will continue in our next class. Thank you. Thank you children.